So let me just do this first example with you. So first, this is two fractions. One is subtracted from the other. They do not have the same denominator, right? They do not have that. So the question I'm asking myself here is, what can I multiply by this one to make it look like this one? If I multiply by 6, 3x, right? So if I multiply this by 3x, I'll have 6x, right? So that's going to give me these like denominators, and here comes the second critical rule. If you do something on the bottom, you also have to do it on the top, right? So if I multiply by 3x down here, I have got to multiply up here as well. All right, so now let's just rewrite it. This will be 1 over 6x minus 3x over 6x. Right? Because 1 times 3x is 3x and 2 times 3x is 6x. So notice now I have these identical denominators. So now I can just write this as a single fraction with that common denominator. And now I'll just go grab these numerators and I'll do that subtraction. So that'll be 1 minus 3x. Can't factor the top, can't factor the bottom. It's fully simplified, so this is done. This is it. This is it. So there's a lot of examples because there are a lot of little details. The same big idea every time, but I'll do a bunch of examples.
So at first, we always try to get the common denominator, then see if we can factor it and work it out.
Well, you want to see if you can factor it at the beginning. Then you want to combine it, and then you want to try to factor it again so you can simplify it, right? So, all right, let's look at this second example here. So the first thing, just like always, if I'm working with fractions, I need to make sure they're both fractions. Right? I need to know that if I just have a 4, I've got that understood 1 in the denominator. So these are clearly different. I can multiply this one by 4x squared and they'll be the same. Right, so now they're the same, but if I did this to the bottom of the fraction on the right, I also have to do it to the top. So my common denominator now is going to be just 4x squared, so I can write these two as a single fraction with the same denominator on the bottom. And then I'm just going to perform this. I'm going to bring that numerator to the top. So this will be 5 minus 16x squared. And just 4 times 4. I cannot factor anything on the top. I can't factor anything on the bottom. Nothing simplifies, so this one is done.
That doesn't simplify.
It does not. Remember, we cannot simplify things that are locked together with addition or subtraction.
Oh, so if it was by itself, we could.
If it was by itself and didn't have this 5 minus in front of it, then yes. But because it's all, the only thing that will simplify with this numerator is another factor of 5 minus 16x squared. It's got to be all the same. Okay? Example number 3, check it out. These are already the same denominator because I want to highlight and bring your attention to something else. You have to remember that when it's in the numerator of a fraction, these things are together. Right? This is the whole thing. So when I combine these, I already have a common denominator, 3. This one I'll write like this, but this negative applies to the entire top of that second fraction because I'm subtracting the whole thing, okay? So in essence, what I have to do is I have to distribute that negative. This will be plus x minus 2. You with me on why that happened?
Yes.
Yes. Minus everything. Not just minus the first thing, minus everything.
Would we have to show the step where
Nope.
before we?
Nope, I'm just showing it so you can clearly see what happens and you don't miss anything. All right, now I need to clean the top of this up. So Combine like terms, this will be negative 3x. 3 minus 2 is 1 over 3. Again, can't factor it, nothing simplifies, so we're all done here also. Okay, again, we want the denominators to be the same so we can combine the numerators and simplify. All right, let's look at this next one. So this one's a little different because I cannot multiply 5 by some number that will give me 9. And I can't multiply 9 by some number that will give me 5. They have no common factors. So what I have to do here is figure out what is a multiple of 5 and 9. Yeah, so I need a 5 over here, and I need a 9 over here. So in essence, when they don't have anything in common, we just add the one that's missing. Okay. Again, if I do it on the bottom, I have to do it on the top. Does it matter that the 9s are on the left and the 5s are on the right? No, it's multiplication. Multiplication is commutative. You can go either way. So what's my common denominator then? 45. So we're just going to write a single fraction with 45 as the denominator. And then I'm going to combine the top. So 9 times 3 will give me 27x minus 2x times 5 is 10x. Combine like terms, 27 minus 10 is 17 over 45. And that 17 is prime, so you're not going to do anything with that anyway. There's no common factors there, so that's just it. All right, next example. So I'm immediately going to notice that, like, there's just no denominator over here, so I'm going to put 1. I can put 1 as a denominator whenever I want to, because it doesn't change. Divide it by 1, it's all the same. So now if I'm looking at these two fractions, the denominator here is x plus 6. This is 1, so I would need to multiply by x plus 6 over here. Now the denominators are the same. But if I do it on the bottom, I got to do it on the top. So this one gets a little tricky. Do you remember what I said? These numerators, these pieces of the fraction stay together. So when you write this one over here, your common denominator is x plus 6. But then you have x plus 6 times 7x plus 5 minus 1.
So you just have to distribute.
You got to distribute this first part and get that handle first. Okay, so that would be 7x squared plus 5x plus 42x plus 30 minus 1. So see what I did here is I just multiplied these together and it got me this right here. And then you just have the minus 1. And then on the bottom is just the x plus 6. And now it's just a matter of cleaning it up. So let's combine all our like terms. This will be 7x squared plus 47x plus 29 over x plus 6. Now at this point, I'm not real sure if anything's going to cancel or not. So I'm going to have to try to factor that top piece. I don't know. Probably want to use your table function for this one. So, it's going to be two numbers that multiply to 203 and add to 47. I know I got 1 and 203. Is that going to work? No. So you can go through, all the factors you want. You're only going to find one more. And it ain't it. Let me find it for you. Let me try. Let me back everything up. Clear 1. Let's see. What are the other two factors? 7 and 29. Do either of those work to factor the top?
No.
No, so it's not factorable. So I'm gonna leave it like this.
Like if it was factorable, we would change it.
You will, if it will factor and something will cancel, change it. If it factors, but it's not gonna cancel anything with the bottom, you're gonna leave it like this. Okay? You gotta check that. In some cases it'll factor, but nothing will cancel, so I want you to leave it spread out on the
So
top.
if we factor it and it can't cancel, we just leave it how it was before.
So if you look, and if I'm not gonna get a 6 out of that, then I'm not interested. I'm like, no way. All right, this one's an interesting one. So remembering from yesterday that special case where you have 9 minus x and then x minus 9, what's the only thing that's different about those? Do you remember? Multiplication by what number? -1. So, to make this one look like this one, all I have to do is multiply by -1 on top and on bottom. All right, because this is actually going to give me, this will make this x minus 9. So my common denominator is just x minus 9. The top is going to be -1, and then you'll have plus 5x. Anything going to factor here? Nah. Or you can always write it 5x minus 1 over x minus 9. Whatever. Both of these are good. It doesn't matter. Okay. All right, that's the -1 trick. Let's go down and look at one that looks similar but isn't. Notice we got a different sign happening here. It's not like the previous one because this one is both subtraction with the order messed up. That's when the -1 trick works. It's not going to work here. These are fundamentally different. So when there are no common factors, because 3 is not a common factor here, these are one thing, you just multiply them both together. So I'm missing an x minus 3 over here, and I'm missing an x plus 3 over here. If I do it to the bottom, I got to do it to the top. And so when you write this out over here, your common denominator, you just leave it like this. That's it. Just put the 2 factors there. Don't do anything else with that. Don't multiply it out. Don't do any of that. So then I'll have, 3x plus 3 minus 7 times x minus 3. Now I just combine the numerator here. This, okay, right there. Well, at this point, the adding the fraction is done. We just have to clean it up and distribute and combine like terms. So this would be 3x plus 9 minus 7x plus 21 over all this. I'm just leaving the bottom factor. 3 minus 7 is -4. 9 plus 21 is 30. This is one of those examples where I could factor a GCF out of the top, right? Everybody see it? 2 is a common factor out there. I'm not going to factor it out. Why not? Right, it's not gonna change anything. Like, I'm just not interested. So I could factor out a -2 up there, but there's no -2 for it to cancel within the bottom, so I'm not gonna do that. We'll leave the top just like it is, and I'll leave the bottom just like it is. If it would have factored, I would have factored that out. I mean, if it would have canceled, I would have factored it out. But I'm just not gonna waste my time. Okay. All right, let's do another one. These are slightly different. Because it's hard to see what they have in common. Notice on all the previous examples, the denominators were already fully factored. You see them? Already fully factored. Is that denominator factored?
No.
Negative. So we got to do that first. So I'm just going to rewrite the whole thing. I'm not going to do anything except for factor that denominator. No. No. Okay, so I haven't done anything yet. I've just factored that bottom piece over there. Notice now that it's factored, we can clearly see what we need to add to make them the same denominator, right? What's the second one missing?
X minus 3.
Yeah, the x minus 3. So now that we've factored it, it's really easy to see what we have to do. So now I'll just do that. Notice now these are identical. Does it matter that this one is first here and second here? No. Why not? Why doesn't it matter? Multiplication works in any direction. 2 times 4 is 8. 4 times 2 is 8. Whatever. So let's write it as a single fraction. X plus 3, x minus 3. This will be 3 plus, distribute this, 2x minus 3. No, wrong.
Minus 6.
Yeah, minus 6. All right, then just clean it up a little. 3 minus 6 is negative 3. Notice I just leave the bottom factored. I'm not going to multiply that back out. Not necessary, okay? That's it. Nothing's going to factor out of the top. Certainly nothing's going to cancel out, okay? Questions about this one? Straightforward, pretty good? Okay. All right, this is my, not my last example, almost my last example. All right. I mean, I cannot see anything common here yet, but I know I can probably factor this, so let's do that. I'm just drawing an arrow just so you can kind of see that I'm not actually doing anything. I'm just factoring it so I can get a better look. 7x on top, multiply to negative 3, add to positive 2. Yeah, 1 and 3, 1 negative. This would be x minus 1, x plus 3. So now it's like, oh, this is fine. All I need is that x plus 3. Easy to see now, so we'll do that. If I do it on the bottom, I'll do it on the top. Write it as a single fraction. My common denominator is just both of those things. And I'll do, 5x plus 15. I'm just distributing this 5. Minus. There we go. We can clean this top up a little bit, right? That'll be negative 2x plus 15 over whatever that denominator is. Here we go. That'll do. Basically, just get the denominators the same. Sometimes you'll